now let's solve some nonlinear inequalities. Not equations, but inequalities. They have inequality signs. First, notice that nonlinear means it's not first degree. It's going to be a higher degree than the first power. We're going to graph the solution set and write the answer in set and in interval form. The first one, part A, we're going to graph parenthesis x minus 1 times parenthesis x minus 4 is less than 0. You see, that's nonlinear because if you FOIL that, you're going to get the highest power to be x to the second power. Okay, let's start. I call it A. We're going to do B on another video. All right, let's start step 1. Get everything on one side of the inequality sign. And we want it to be on the left, even if we have to flip it around. We want everything on the left side, and we're going to factor the non-zero side. Okay, so it's actually already done. We don't need to move everything to the other side. It's already on the left side. We don't need to factor. Because it's already factored. We've got 0 on the right, the factored form on the left. This step's done. Let's go to step 2. Set each of your factors equal to 0 and solve. Okay, first factor is x minus 1. Set that equal to 0, and it equals x equals 1 when you solve it. The other one is x minus 4 equals 0. We're going to set that factor equal to 0 also and solve. So when we do that other one on the right, it gives us x equals 4. So we have two values. We have x equals positive 1 and x equals positive 4. Those are called our critical values. We got them by taking the factored form of the inequality, setting each of the factors equal to 0, and solving. Now we're going to use those critical numbers to partition a number line. And we're using just the real solution. See, sometimes you can get answers when you do this that have the imaginary number I in step 2. You wouldn't use those, only the real ones that do not contain I. You use the real ones to partition, to bust up a number line. So let's see. Here's our number line. It's an x-axis, and we have the number 1, and to the right somewhere we have the number 4. Make dotted lines to bust it up into 1, 2, 3 sections. Step 4, find the sign of each factor from step 1 in each of the 3 regions. Okay, the factors in step 1 were x minus 1 was one factor, and x minus 4 was the other factor. Now we want them to multiply together and give us a number that's less than 0. To be less than 0 means we want their product to be negative. Then we'll look at step 5, find the sign of the product of each factor in each of the regions. So first we'll write our factors up above the x-axis. And we'll consider values of x in each of the 3 regions, plug them in our head, we'll figure out if each of the factors is either positive or negative. So the factors that we're looking at are parenthesis x minus 1 times parenthesis x minus 4. Okay, let's make some parentheses in each region. And now let's choose a value. Choose a value in each region. First, choose a value for x that's left of 1. In other words, it's any number that's smaller than 1. I think a good choice would be 0. Let x equal 0, and in your head, plug it into the two factors. 0 minus 1 is a negative result. 0 plus 1 gives 0 minus 4 gives us a negative result. So we have a negative times a negative in the leftmost region. You multiply those together, and down below where the arrow is, it gives you a positive result. Now let's consider the sign of these two factors, x minus 1 and x minus 4, for values of x between 1 and 4. Those are values in the second region. Let's see, let's choose a number 3. 3 lives between 1 and 4. If you plug 3 in for x in the first factor, x minus 1, it gives you 3 minus 1, which is a positive result. And then if you plug it in for the second factor, x minus 4, 3 minus 4 gives you a negative result. So in the center region, for x's in the center region, you have a positive factor times a negative factor. If you multiply a positive factor times a negative factor, look down at the arrow in that region. Together, that will give us a negative product. Finally, in the last region, choose any value of x that's greater than 4. Let's choose 100. X equals 100. When x equals 100, the first factor x minus 1 is 100 minus 1, which is positive. The second is 100 minus 4, which is positive. You multiply a positive times a positive, it gives you a positive result. So we can see in our sign graph, for values of x smaller than 1, we get positive product of the two factors. For values between 1 and 4, we get a negative result for the two factors multiplying together. And for values of x greater than 4, we get a positive result. Now, step 6 says shade the region that makes the step 1 statement true. Well, step 1 was the original x minus 1 times x minus 4 is less than 0. To be less than 0 says when you multiply the two factors together, they have to give you a negative result. Well, that only happens for values between 1 and 4 on the sign graph. So we're shading everything between 1 and 4. Everything between 1 and 4, all the x values between 1 and 4. Step 7, if the inequality sign had an equal portion in it, include the endpoints. If it had no equal portion in it, exclude the endpoints in your graph. Well, our original problem at the beginning had an inequality sign that had no equal portion in it. It was only less than. So that means we're going to exclude the endpoints. And that implies we're going to put round brackets on 1 and on 4. So we're going to go back up to the number line where we have the graph, and we're going to put round bracket on 1 and a round bracket on 4, indicating that we're excluding these endpoints. Step 8, conclude. Set of solutions for the given problem, x minus 1 times x minus 4 less than 0 is, and then we just write the graph notation, the interval notation, and the set notation.